Now, if we have a few more minutes, if you have a couple of extra questions, I know we're running up to the next activity.
We're going to finish up some stuff for the day.
Okay, okay.
This is the last big
This is it. All right.
share our concept.
All right, excellent. Well, are there any questions? I see one already.
One picture you showed of the delta, the whole thing, the E.
The Eberswalde Delta? Mm-hmm.
We had an activity we did earlier in the week that
Okay.
was identifying different ways things looked on the Earth, and they had that one, and it came down to, from this person that did their presentation, that there was an argument about whether that was a lava flow or water flow that's still raging. So are you on the water side?
I'm very firmly on the water side. My PhD advisor is a sedimentologist, and I think if I said that was a lava flow, they'd take my PhD away. Yeah, I'm very firmly on the water side, yes.
Is there still some question among other people that it would be lava flow, or is it the region?
I'm not as familiar with that side of the literature. I can tell you that when we look at things, there's a lot of debate about how something formed, because especially from satellite, we're only working with analogs. And so, like you brought up before, we have to argue about what is the most likely option for the formation of certain structures. And sometimes when we get to the ground with the rovers, we find that we were incorrect, and we can adjust our interpretation accordingly.
I will say something about that question, Eberswalde. When you look at it in detail, there are very definite indications of the channel deposits that match exactly what we think happens on terrestrial delta. So this was one of the possible landing sites for the Mars Science Lab, and so it's been examined in excruciating detail, and and it really is distinctly different from what we would expect to see in a lot of those.
Yeah.
This particular case is not, there's no controversy at all. There are other things where there's questions, but this is one where it's really very, very
Yeah. Yes.
Since we've been on Mars for quite a few years now and haven't found life, what's the deal with not taking like bacteria up there
Well,
through the rovers and stuff?
you know, we've had 3 rovers, a couple of landers. So even though we've been exploring Mars all these years, the footprint we've made in our exploration is so small compared to the planet. It would be irresponsible of us to knowingly send bacteria up there. We know that there are probably some spores you just can't get rid of when you send them up there. But you don't want to colonize a planet that you don't know what's there, because we would never be able to tell if it were actually Martian life or if we had unknowingly seeded the planet.
So here's a fun aspect about that. That's just asking again for what I think is the best job title I've ever heard of, and this is NASA's Planetary Protection Officer. And they just advertised again. Actually, I would say Amy would be a good candidate. She'd be an astrobiologist to apply for that job. But I've known several of the people in the past, including the guy who's in charge of our mission, had that job for a while.
I would love to study if there were microbes on Mars, that would be where I would line up to go work. So
it's a major aspect of discussion, and actually International COSPAR, International Committee on Space Research, there's international treaties about planetary protection. We would be in violation of that to knowingly send
a petri dish.
to Mars that we thought could propagate. And that's the key word.
Yeah.
We know there's spores on these spacecraft, but we're absolutely certain that there's no way for them to reproduce in the locations where we send the spacecraft. But this leads to other interesting limitations. MSL, with its nuclear power source, was not allowed to fly over ice when it was coming into land, in case it crashed into ice and created a warm puddle that we're stuck to grow. So there's a huge amount of effort and expense and thought to prevent that kind of
So
contamination.
NASA
Yep.
would never talk about terraforming?
Well, so one of the goals of the Curiosity rover was to understand the radiation environment on Mars, and that's for future human exploration. You know, we've pictured terraforming as like, I don't know, big towers pumping out oxygen, you know, from sci-fi, but terraforming is a ways away. And so it's a discussion that we have a way to
More
go.
about that too, because in the 60s, the agreement was made that that we would protect Mars for 50 years, because it was inconceivable that, you know, that it would be more than 50 years before people are walking around and this became a mutant topic. So my guess is that that will be extended, but the original agreements were to protect Mars for 50 years, to leave it for scientific investigation. Again, I think that'll be extended probably another 20, 30 years, but that was, so until that treaty ends, no, we would not be allowed under international treaty to attempt something like that.
Is it possible to send like really, really like actual H2O, like nothing else in it, to Mars?
Oh yeah, in fact, Curiosity has, and all kinds of Viking had it. They had liquids in Phoenix for their experiments, and Curiosity has all kinds of vials of liquid.
But they're small, like, little for experiments. It's not like shipping a bunch of water up there
I
to
just
see what would
thought it'd be
happen.
cool to like put a big tub of it on there and see how long it takes to evaporate or something.
Yeah. I mean, I feel like you could probably estimate that from what we saw on the Phoenix legs over the given course of time we saw it disappear. But yeah.
Just on that same thing, so Zach that was in here the other day, a private company that wants to fly to Mars in 10 years, if that treaty's renewed, they wouldn't be able to do that then.
That's correct. I mean, I think they would have to abide by that kind of treaty. But the idea is, the idea was that we would explore Mars until we send people. Once you send people, are, you know, are dirty. So it becomes less of an issue once people know that. But it was thought in the 60s that, you know, we would have humans walking all over the place long before today. So that's kind of the idea.
Amy, I know that there's been some speculation that there might still, even today, be a few underground water, maybe even hydrothermal sources. What do you think about that in your studies?
We definitely have evidence for ancient hydrothermal systems. I think if you had an impact big enough, you would certainly generate a modern hydrothermal system. Since we have like that evidence for the water that comes out of the side of the crater walls and pours down the craters during the spring and summer, I think it's absolutely fair to think that there are ice water reservoirs, maybe what you would picture groundwater to be, but it's all frozen. There's ice water reservoirs in the subsurface, and we really don't know how much there might be, but it's really exciting to consider the possibilities for future exploration of Mars. What may be there, and maybe there is life there after all, and it's just hiding underground using those little water reservoirs. We don't know yet. It's worth continuing to explore. Yes?
What's the deepest that they have dug down, and have they measured the temperature as they have gone down?
So our drill is the deepest that we have gone into the subsurface, and 6 millimeters, right?
6 centimeters.
Centimeters.
Actually, I think we dug deeper than that with the wheel. So
Yeah. Yeah, into loose material.
The Burr rovers and we dug down similar depth with the SCOOP.
Yeah. And so actually the InSight mission, I believe, so InSight's a new lander that's scheduled to launch in the next less than 10 years. And its goal is to understand the seismicity of Mars. And so it's actually supposed to be able to have a bit of a drill that would go greater than 6 centimeters, but not more than a meter, I would guess. Probably far less than a meter depth.
There's no curiosity to go deeper?
I don't think that Mars 2020 is, if Mars 2020 were to fly in 2020, I don't know that it would have much of a drill. I think ExoMars, the European Space Agency equivalent, may have a bit of a deeper drilling capacity, but You know, it's not, you know, oil drilling, big, deep, long cores. Yeah, no cores yet from
That would seem
Mars.
like an extremely interesting.
Yeah.
The idea with 2020 is to acquire cores that will be stored in a cache for future return to the Earth. So that's the whole purpose of the 2020
Mhm.
mission.
But we're not talking a core, we're talking a core.
They're small.
Oh.
Because, yeah, the mechanism to, the cache, you know, we'd have to, so 2020 is part of a 3-step plan. We send a machine to collect the sample and cache it. We send something else to grab it and launch it into orbit, and we send a third thing to scoop it out of Mars orbit and bring it back to Earth. So the core can't be terribly big.
That's kind of a question that I've been having. The instruments like the spectrometers and things like that that are on the surface now
Mhm.
on Mars, how much better do we have them? How much better are the instruments on Earth? Like, is a sample return mission, like, would it really be worth the expense and the technology to do all that and the time to do all that? Would the science that we would get from bringing those rocks back to Earth really
So,
be better than just doing it?
Mhm. so I would say a resounding yes.
I know it's cool to get a piece of Mars back.
It's
but
not
other than
just
the
cool.
factor-
It's not just the cool factor, and I love Mars, and that would be awesome. Think about there are 10 instruments on Curiosity, and 4 of them have cameras. So there's such a limited payload that you can launch to Mars. There is an incredible variety of instrumentation on Earth that there's no way to send to Mars. You can't send a scanning electron microscope, and if I wanted to look for a little tiny bacterium, I would use an SEM. Yeah, you could do all kinds of biological studies on the samples. You could do far greater detailed studies than are going to be capable for many, many years by sending rover
And
missions.
what's the timeline for sample return mission? Any ideas?
The future.
Well, the 2020 is to do the cache, and then the potential is to do that. There is talk of using something like the new NASA rocket, which would be a huge rocket to do a one-shot deal, or you could use the SpaceX Falcon 9 Heavy that could enable a single mission. But the budgets for NASA's planetary exploration just do not.
They don't match our goals right now.
We're the next space telescope, the James Webb, is breaking our back financially, and that costs about 3 or 4 times what Curiosity costs. It's not great. Now, in the context of building an LA freeway, they're comparable. Just to put things in context.
I don't know which would take longer, an LA freeway or a mission to Mars.
Yeah.
Yeah. Were there any other questions?
We are just about out of
All right.
time. First of all, I'd like us to thank you